So hello everyone, welcome back once again in my tutorial learning program with R. So in this video we will see about matrix and its operation. So exactly the first question comes in mind, that what is matrix? So matrix is a vector represented and accessible in two dimensions. Therefore we can say almost all the operations which are applying on vector is also can be applicable on the matrix. For example, each type of vector like a numerical vector or logical vector has its matrix version. So the first thing is we have to check that how to create a matrix. So there is a very simple operation, that function, that is matrix. So inside the matrix we are creating a vector, and in that we are putting the value 1 2 3 4 5 till 7. By this we will create a matrix by which we are having one column and 7 of the rows. Okay, so but right now suppose if you want to put into column and row formation, so what we have to do, we have to specify some definition of that n calls is equal to 3, means I need 3 columns. Okay, so what happened, once the 3 columns will be put here, automatically 2 row, means first 1 2 3 formatted is going here, and automatically the second row is started and it will fill the data. Okay, so row into column format, so 2 into 3 format. Fine. Right now able to see here that by specifying n call is equal to 3, we mean that the provided vector should be regarding as a matrix with 3 columns. Okay, and 2 rows automatically assigned, right? So you may feel the original vector is not an straightforward as it is representation. To make a code more user friendly, we can write the vector into multiple lines. Okay, so in that we will use by row function as a true and false condition. First of all, I'm going to do by row as a true option. Okay, so by row as a true, you can able to see here that I'm having 9 value with 3 columns, so automatically 3 row is declared, and the value is determined into the format of left to right formation, like 1 2 3 4 5 6 7 8 9. Now let's check what happened if we put as a by row as a false. In that condition, the row is first, the value first come as a column way, so 1 2 3 4 5 6 7 8 9. So you are able to see here that it is very convenient and it is very user friendly to do the representation by using the by row options. Now often we may need to create a diagonal matrix, right? So here we will use diag function in the most handy way to do this. Okay, so right now diag1, it means 1 row 1 column and it is create a unit matrix. Okay, if we are giving just a number and providing the how many rows we want, so we'll get a diagonal matrix with the particular value. So here 3 3 3 and the rest value is 0, and if we put and diag is equal to 4, so we will get unit matrix with the diagonal value. So it is quite easy and handy to understand how to create a diagonal. The next we will see today about the naming of rows and columns. So by default, creating a matrix does not automatically give name to its rows and columns. Sometimes it is useful and straightforward to do. So when different rows and columns have different meanings, we can give row name and or column name when creating the matrix. What is the way to do that? So first we have to assign and try to create a matrix. After that, during the assign, we will provide that how many rows we want. Right now we are creating that how many rows. After that, we are assigning the way how our objects and data will be stored into the system. After that, we are using dim names and we are providing the list formation. Like in the first one, it is coming as a 2 row will become as the R1 and R2, and column names would be C1 and C2. After that, you are able to see here that right now we are having by row is equal to true. So it is the value is arranged into the format of the first, they are arranged into the row format and then go to the next row. Now again I'm going to do is by using by row false option, so just the value will be opposite of that. It's also, you can understand that it is just like a transpose conditions, right? Okay, we will see that what is the another way of the naming. So for that I'm just going to put an example, like a more realistic way to understand it. So right now, what in this example, we are going to create a matrix that is name is city temperature, and in this matrix we are having some particular cities, means for some particular countries, and the particular day wise the temperature formation. So here the temperature is listed as a vector, and here after that I decided that how many columns we want, and here columns is equal to days name, and I'm providing that by row is equal to 2. It means first 43 will come, 41 will come, then 39 will come, then 32 will come, and it will be like that. Okay, after that we are providing that row name is the city temperature of matrix name is city temperature will be the India and USA. It means the first row will be India and second row will be the USA, and the colnames will be the first column is Monday, second column will be Tuesday, and third column will be Wednesday. So it is well manner to declaring the naming, and it is well understandable format. So let's run it. Row name, after that we declare the column name, and after that if we print my matrix, that is city temperature, so you can able to see the first row is India, second row is USA, first column is Monday, second column is Tuesday, and third column is Wednesday, and the particular temperature is according to that one. So you can able to see here that it is really very good way to representation of a matrix into naming formation by using this method. Okay, so suppose I'm creating one matrix as a matrix, and in this one we are having value 1 2 3 4 5 6 and 3 columns. So just check out the matrix, and this is the matrix right now, the matrix 1 and 1. So let me tell you that how it is going on. So the first position is coming with the row, and the next position is coming with the column. So you can understand that one comma, so one comma is coming here, that's fine. So it will search into this row, after that one column, then it will search into this column. Okay, so this value, the one value will be printed. Okay, so let's go and check. In the same way, I'm doing all the operation one by one. If you well aware about my vector subsetting video, then you can easily understand that what operation I'm doing here. Now let's discuss about a matrix 1 comma 1:3. It means it will first check my first row, that is this is the first row, and in the column way it will check that 1 to 1 2 and 3 value. So it will come like this value, and we are getting 135, the first one value. In the second matrix, in the second subsetting, what we are going to do, the first column and the 1 and 2 value. So it will give me the value as 1 and 3. In the second way, I'm having one matrix as a city temp here, and we want first to read the value from India row and USA row, and the temperature should be from Monday and Tuesday. So it will give me the value exactly like that, and we are using the value for Monday and Wednesday, and Wednesday and Monday. So it is as you want, you can access the value. Okay, we are going to check the matrix value by using VR logical operation, and it will be give me the answer. Okay, we are having true and false condition or not, and all things. So first we will check a matrix having all the value greater than 2. So yes, let it will be go and check one by one. The next we will discuss today about the matrix arithmetic operation. So all arithmetic operation for vector also work with the matrix as if they were in the vector operations. So these operations perform calculation element wise, except for matrix only operators such as matrix product and all that. Now what I'm going to do, I'm just going to add a matrix with the another a matrix. Okay, so it is quite handy, like 1 is add with 1, 2 is add with 2, 3 is add with 3, 4 is add with 4, 5 is add with 5, and 6 with add with 6. And this is like normal operation of the arithmetic. Okay, so this is the subtraction, this is multiplication, this is divide, this is modulus. Okay, in the last today we'll discuss about the transpose of matrix, that is t function. Okay, so for the t function, first let me show you that what is the value, then it will be very good. Okay, check the what is the value of a matrix. So this is the value of a matrix. Right now what I'm going to do, I'm just going to transpose. Transpose means it is just going to opposite the value. So fine, that row becomes column and column become row, so the value is changed. Okay, and now let's check about that what is the value of in the city temp. And after that, if we go and check here the city temp, then you can able to see that the right now here the Monday, Tuesday, Wednesday is the column and Indian USA is a row, but right now after transpose it is giving me this value. In today's video you can understand that vectors and matrices are sufficient for many use cases, right? However, some particular problems need a data structure with even higher dimensions. So in the next video we will briefly introduction about the array, and we will see how these data structures share similar behaviors. Till that, please subscribe my channel as well as comment down if you're having any problem. Thanks.